Hey folks, I hope you're doing well today. I'm going to be talking about cover crop nitrogen scavenging credits that farmers in the Central Coast region of California can get as part of this new regulation called Ag Order 4.0. I'm really excited to share with you some of our research results because I think it's really going to help farmers to get these credits in a much easier way than we knew about, say, even a year ago. So I'm going to focus on three main things. First, I'll talk about the different types of cover crop nitrogen scavenging credits. And then I'll talk a little bit about the research that we did to help farmers get the credits. And then lastly, I'll walk you through a scenario of exactly how a farmer would get that credit. All right, now let's keep in mind that cover cropping with non-legumes in these systems is considered a best management practice because it can help us to reduce nutrient losses, especially nitrogen losses down into the aquifers. There are some other benefits to soil improvement and many other things from growing cover crops also. Here's a table that I put together that talks about these credits or these incentives. That's why the carrots are there. So there's a standard cover crop credit, which is a smaller incentive, a smaller carrot, and then there's the calculated credit, which is a much bigger incentive. Now the way that they are similar is that they both require the cover crop be a non-legume and that the cover crop be grown from October to April for at least 90 days, and that it also provides or produces a shoot biomass of 4,500 pounds per acre of oven-dry biomass. Now, the way they differ is that the calculated credit, which is the bigger carrot, the bigger incentive, that also has a carbon to nitrogen ratio requirement of 20:1 or more. All right, so the goals of this research were to try to develop methods where we could estimate cover crop shoot biomass and carbon to nitrogen ratio without the farmer having to send anything off to a laboratory or do other complicated analyses. So what we're trying to come up with are simple and fast and relatively accurate methods that are farmer friendly and field based. Ones that you can go out into the field, take some measurements, and you'll know right then and there you've met the requirement or you haven't met the requirement, you need to wait another week or so. So things like that. So to try to address this, we did research from Santa Barbara County up through Monterey County and then to Santa Cruz County. And our research collected nearly 300 samples. It came from organic farms, conventional farms, also from 5 replicated trials at the USDA Organic Research Farm where I work. And these were mainly focused on overwintered cover crops, but we also had some summer and fall cover crops in there. The cover crops we focused on were Merced rye on the left here and Pacheco triticale. You can see Merced rye tends to close its canopy faster than Pacheco triticale does. And here the cover crops are a little bit later as they're starting to get some height to them. And then this is quite a bit later in the season when they're actually getting close to where they could actually set some viable seed. So a farmer wouldn't usually let their cover crop get this old, but I just wanted to show you how they look different. So Merced rye is quite a bit taller than Pacheco triticale is. All right, so here's a really, really nice graph. I love this figure because what it shows us is that we can estimate shoot biomass from shoot length. So this is a figure for Merced rye. Let me orient you a little bit. So here's the shoot length on the x-axis in centimeters or on the upper one in inches. And then on the y-axis, we have oven-dry shoot biomass in kilograms per hectare or pounds per acre. And you can see here's the ag order requirement of 4,500 pounds. And you can see as the shoot length goes up, the biomass goes up also. So Merced rye needs to have a biomass, or a shoot length, I should say, of about 31 inches or so in order to hit the ag order requirement for its biomass. Now here's the same thing for Pacheco triticale. For it to hit the biomass requirement, it only has to be about 27 inches tall. What you can see with both of these cover crops is that shoot length is an excellent way to predict oven-dry biomass. So that was a real nice finding from our research. A little bit about shoot length now. So cover crops like cereals like this, they produce many different stems. We call these, the side ones, we call those tillers. When I'm talking about shoot length, I'm focused on the main stem shoot length. And so we are actually measuring the length of that main stem as if it was completely straightened out. And the reason for that is that when you go out to sample a field, you often will find plants, some of them are straight up, other ones are crooked and all over the place. So our measurement was focused on the shoot length of the main stem as if it was completely straightened out. I'll make another video with more details on this. So how would a farmer go out there and measure their field so that they can get their biomass estimate? What I would suggest, so here's an example with a Merced rye field and a Pacheco triticale field. And what I would suggest is a farmer go out there, you walk a diagonal across the field, and you take 10 samples. At each point along that sampling area, you'd put your hand down to the ground, you'd put your hand around some plants, you'd dig them up, and then you randomly choose one of the plants. You put it in a bag and bring those 10 plants out of the field, and you're ready to measure the length of the main stem on each of those 10 plants. You're also going to use those 10 plants to do something else. You're going to estimate the carbon to nitrogen ratio. And what we're going to do to try to get a good number on this is we're going to use this thing called the Feekes scale. It's a growth stage scale for tracking the development of cereal crops. It's widely used throughout the United States. And what it does is it gives us a number from 1 all the way up to 11 for the different stages, from the seedling stage to tillering to stem elongation, heading out and then flowering and then grain filling and ripening. So what we found is that the Feekes growth stage is an excellent way to estimate the carbon to nitrogen ratio of the cover crop. So here's a graph for Merced rye, and we've got the Feekes scale here on the bottom on the x-axis. Then we've got the carbon to nitrogen ratio here. So you can see there's the 20:1 number for the ag order that's required. And notice that our fitted regression curve, this black line here, that crosses that requirement of the ag order right about Feekes 9. So we can use Feekes 9 as an indicator of when the carbon to nitrogen ratio requirement has been met for both Merced rye, and here it is again for Pacheco triticale. See, it crosses right around 9. So this is very exciting because we can use this and farmers hopefully find it quite helpful. I'm going to walk you through now a scenario for how a farmer would be able to get this calculated nitrogen scavenging credit for a Merced rye cover crop like what you can see right here. Let me give you a little bit of information. So this is a cover crop. Let's just say it was planted in October 15th. 92 days after planting it was sampled, so it met that 90-day requirement. So the shoot length's 36 inches, the Feekes growth stage is 10. So what we first need to do is we need to estimate the amount of oven-dry biomass, and we're going to do that using this table from the ag order. Now this table is based on this figure that I showed you earlier, and what you can see for a average shoot length of 36 inches, here's our biomass in pounds per acre. So we put that on our little sheet here. Now we need to get a table for the carbon to nitrogen ratio. So we can see we've got here's a table with the Feekes scale, and then we've got our estimated carbon to nitrogen ratio as well as the estimated nitrogen concentration. So for a Feekes growth stage of 10, which is actually above what's required for the ag order, we would have a carbon to nitrogen ratio of 27. We put that along with its corresponding nitrogen concentration into our sheet here. Okay, so next we need to just calculate the amount of nitrogen uptake by the cover crop. So to do that, we take our biomass, which we've already estimated, and we multiply it by 0.98. And then we multiply that by the percent nitrogen, and we get 87 pounds of nitrogen per acre were taken up by the shoots of that cover crop. So that's the total nitrogen uptake. We're going to take our nitrogen uptake, the total amount, and then remember from our calculated credit, we get 97% of that. So multiply the 87 pounds per acre of uptake multiplied by 97%. So there you have it. 85 pounds is a pretty nice credit. I think in many cases farmers will get even more than that, up close to 100 or more. But this just shows you for the standard credit, you only got 30 pounds. For the calculated credit, you can get close to 3 times more. Anyway, so there you have it. So that's how you would calculate the calculated cover crop nitrogen scavenging credit for a Merced rye cover crop. Hopefully you find this helpful. I'll be happy to answer any questions that you might have about this.